Okay, today we're talking about 5.33, force and motion in 2 dimensions. We are going to be calculating the tensions for multiple strings and ropes tied together. It is going to basically be an accumulation of everything you've learned in this chapter put into one, plus the vectors. Remember we did the vectors at the beginning of the chapter, we did the vectors at the beginning of the year. We're tying that into this because our forces are no longer going to be in x and y, they're going to be at somewhere in between x and y. So just like we did with vectors, we got to break them into components using cosine and sine, and then after we get all done with that, we might have to use this to put them back together. So there's a couple of things to remember, that tension always comes in pairs. In order to solve for that tension, you need to cut the strings in half. Also remember that equilibrium means that there's no acceleration, so this happens at a constant velocity or at zero velocity. This allows us to set the acceleration equal to 0, which simplifies our equation. Okay. So this is an example of an equilibrium problem. We have a sign hanging from 2 strings. So the weight of the sign is going to be a force downwards. You see the tension in A is going to be kind of up and to the right here, and the tension in B is going to be directly to the right. So how do we solve things like this? We know the forces in the x direction and the y direction have to add up to equal 0, because F equals NA, and A is 0 here, so F has to be equaling 0 as a total. So that means that if we add up the y stuff and the x stuff, it should be 0, but this one's at an angle. So we'll have to break it into the x component and y component, and then add it up, and then set it equal to 0. So that's why it's so confusing, because you have to do vectors first and then use forces. So we're going to go back and forth between that. So I'm going to do it with this problem, and this might take all class period.
This one problem?
This one problem. So make sure you have an entire piece of paper to write on this. If you're writing on the bottom one, you might want to move to the next piece of paper. It's going to take a little bit. Again, I'm going to do my best to explain it thoroughly, but still be moving at a good pace, because it would be really nice if I could get through 2 problems. Okay, there's 2 strings. One has an angle of 40 degrees, and the other has an angle of 30 degrees from the ceiling. So it's hanging from the ceiling. Again, it's hanging, not swinging, not in an elevator, just hanging from the ceiling. And it's attached to a 3rd string. So basically we have the ceiling, we have 2 strings attached to each other that's attached to a 3rd string like this. A mass of 30 kilograms. Yeah, you can write this. It hangs on the end of the 3rd string. Now we want to know what's the tension in each string. So we have basically string A, B, and C. So I'm going to draw my forces on this. So this string has tension. Remember, forces come in pairs. This string, which we'll call B, has tension. And this string, which we'll call C, has tension. So each string has a pair of tensions. And then this is an object, and it has weight, because it's an object, which we'll call mg. Now, looking at this right off the bat, what is a spot that we can isolate and solve for easily? Just like one of the tensions is really easy to solve for. C, right? Why C?
Because then the other 2. I'm sorry. Because then the other 2 are still connected, and you're isolating the box. And you're getting
Good. So isolate the box. So we're going to just look at TC and the box. So you're cutting the string for TC, and we'll just solve that real quick off the bat, on the side over here. So we're going to look at the sum of the forces of this box, and we see that we have TC up, mg down, and it's equal to NA. What's A in this case?
0.
0, because it's just hanging there. So this is 0. That means that TC equals mg. And if you'd like to, you can solve right now for TC. Because we have mass, which is 30 kilograms, right here. Kilograms. We also have, this is 40. This is 30. So this is 30 times 9.8, which gives me like 294, something like that. Yeah. So that gives me one of my tensions. Nice and quick. That one's easy. Unfortunately, A and B are not as easy to solve because A and B have these funny angles, which they're not in the x direction, they're not in the y direction. So we have to figure out how much they're in the x direction and how much they're in the y direction. That's what makes it so hard.
So is all of your homework going to be just like tomorrow?
No, not forever, just tonight.
Questions?
Okay, so we've solved the first one, nice and easy. Now we have to attack this part. So what part of this do we want to isolate? What do you mean by either one?
Can't you do like either the TB side or the TA side?
Well, let's do all of it together.
Oh.
So we'll cut the strings of every single one. We're going to cut this string, and this string, and this string. So now we can solve TA, TB, and TC all at once. Again, it's kind of nasty, but that's what we're going to do. So I'm going to redraw this kind of to the side so we can kind of zoom in and look at it. So this is TA, this is TB, and this one's TC. Now, if you just treat these as straight up vectors, how would you solve? Well, you can't just add TA, TB, and TC together because they're at angles, right? We have the x component and the y component for each one of these. So if we're looking at them as vectors and we need to know their components, remember the x component is going to be m cosine theta, and the y component is going to be m sine theta. So we know magnitude is just going to be TA, TB, and TC, so how are we going to find the angle here? You guys remember what angle to use? No, not 180 because we've got some angles going on here. So let's start with the easiest one. What's the angle for TC? 270, right? It's the proper angle. So this one's 270. They're all proper angles here. Now, what is the angle for TA? If this is 40, that's this right here. If this is 40, what is this? 40. Something about a transverse between two parallel lines, opposite interior angles. Okay, now a little bit trickier. If this is 30 degrees, how are we going to find this angle? Remember, always from the positive x-axis. How would we find that angle?
Subtract all of those from 270?
Nope.
From 360?
Nope.
I don't know.
Okay, what's this angle?
30.
30. So what would this angle be? 150, right? Because the whole line is going to be 180 minus 30 gives us 150. So now we have the proper angle for TA is 40, for TB is 150, and for TC is 270. That part right there confuses a lot of people. And I mean, if you stare at it long enough, you should be able to get it.
Miss Hill, I don't understand when you put the green angles in.
Oh, that's what was given from the problem.
But how did you find the other angle?
This one was 40. It's the opposite interior angle of a transverse parallel. It's a geometry thing. Like if this one's 40, then this one's going to be 40. If this one's 30, that one's going to be 30.
Is that like that Z thing?
Yes.
Okay. Yeah.
Okay, so we've got the proper angle. We know that we're going to have to do vectors, x and y, but it's still forces. So what's the equation for force? F equals ma, right? So if we look at F in the x direction, the sum of the forces, looking at our free body diagram, this is our free body diagram here. What are the forces in that free body diagram? Just looking at this, we've already labeled them. The stuff in blue. So we have TA, TB, and TC, right? Those are our forces. We're going to look at it in the x direction, so this needs to be our x components. So we'll do the x components for each one of those. And it's equal to MA. What's A in this case? 0, because it's hanging.
Wait.
So this will be 0. You got it?
What about the mass?
We already dealt with that in this picture. And we solved for TC, which makes an appearance here. So it'll cancel out. It'll fix for it.
Is it because since gravity is solving that equation too, we're not putting it inside the x component of TA, TB, and TC?
Correct. We're only looking at this. We don't see any G's here, so we don't need to use it. Just this one goes here. Okay, now we're going to do the same thing in the y direction. Some of the forces in the y direction. In the y direction, what are the forces? What are the forces in this picture?
TC.
TA, TB, and TC. All of them. Because TA and TB are at angles, so they have some y component. And we'll find that y component using the equation for the y component. In the y direction, what's acceleration? 0, still, because it's still hanging. So this side's 0, hanging. Okay, so basically what needs to happen is we're going to need to find the x components of A, B, and C, add them up and equal 0. Then we have to find the y components of A, B, and C, add them up and equal 0. Good? Okay. So we're going to do that. We're going to do that over here. We're going to do TA. We're going to find its x component and its y component. So TA, we don't know what TA is, so we're just going to put TA as our magnitude, because I'm using these. For TA, it's going to be magnitude, cosine, and its angle, which is 40. And then we're going to do it in the y direction. TA sine 40. Now we're going to do TB. Same stuff. TB, cosine. Now we have to go and look at TB's angle, which is 150. Again, always remember that you're going to measure from the positive x-axis, so they all have the same reference point. If you put in 30 here, it's not going to know that it's 30 on the left, and it's going to think that it's 30 on the right. But it's not 30 on the right. It's 150 from the right. So TA is 40 from the right, TB is 150 from the right, and TC is 270 from the right. It's always got to be from the right. If you go and change it, then you're not going to get the right answer, because it's going to think that everything's from the right when you're telling it from the left and from down. All right, so this is going to be 150 I hat, and then same thing over here, TB sine 150 J. Last one, TC. What's nice about TC is we actually already know that TC is 294 from what we did earlier. The magnitude. So the magnitude is 294 cosine, and then we look at its angle as 270. So now what I'm going to do is I'm going to just go and simplify these things a little bit so that we just have some numbers to work with. So cosine 40 is 0.766. So this will be TA times 0.766. Sine 40 is going to be 0.643. Cosine 150, negative 0.866. And sine 150 is 0.5. 294 cosine 270 is 0. So this whole thing is 0. That's kind of nice. And then 294 sine 270 should be negative 294. Okay, did I lose anybody when I did that? We're good? Okay. BCC, you guys have about 4 minutes. Just so you know. So just a quick rundown. Basically, we're going to add up all the I hats, set it equal to 0. Add up all the j hats, set it equal to 0. You're going to end up with 2 equations with 2 unknowns, and you'll substitute and solve. So that's where we're going to go, and just in case you guys have to. Okay, so we're going to look at the x stuff, which is this equation. So here's our x stuff. We're going to do TA 0.766. That's this. So basically we're adding all these things up, right? A, B, and C, and we're setting it equal to 0. So we're going to go TA 0.766 plus TB negative 0.866 plus 0 equals 0. So the 0 is here and here. Yes? I was just going to simplify.
Oh, just kidding.
Okay. So this is basically 0.766 TA equals 0.866 TB. Yeah, I moved it to the other side. So now it's positive instead of negative. And do you guys want to solve for TA or TB? TA? Okay. Doesn't matter which one you solve for. TA is going to be 0.866 divided by 0.766. 1.13. Now this is not an answer because it's 1.13 TB and we still don't know what TB is. Luckily, we have another equation that has TA and TB in it. So we're going to use that equation and it's going to end up something like this, and then we could plug TA in and solve. So you can see why this is a nasty problem. These things include vectors, which we learned at the beginning of the year, forces, and free body diagrams, which we've learned in this chapter and the previous chapter, adding up those vectors, and then, of course, algebra, geometry, and substitution, which is algebra and algebra 2.
Can I just say this is ridiculous?
We just want to make sure that you're cross-curriculum. Yes?
So would you plug that, the TA equals 1.13 TB into that TA plus TB plus TC equals 0?
Well, actually, this is where it came from.
So then where
So I'm not finished yet. I just wanted you to catch up. I got one more equation to do. Okay. The last equation, here we go, is this one. We're going to do this one now, the y stuff. It's still TA plus TB plus TC equals 0. So we're going to do this stuff now, add it up and equals 0, because that's what our equation said. So this is going to be TA times 0.643 plus TB times 0.5 minus 294 equals 0. So now we have two equations. the X stuff and the Y stuff, two unknowns, TA and TB, and we can plug it in and solve.
So now we're going to solve for B.
Now we're going to solve for B, yes. So I'm going to plug in this guy right here. So that's what I'm going to do here. I won't say everything that I'm doing. I also moved 294 over to the other side while I was at it. Let's simplify. We get 0.727 TB plus 0.5 TB equals 294. That gives me 1.22 TB. And 294. Actually, it's 1.23. Should be 3 instead of 2. There we go. And that gives me 239. So TB, right over here, TB is 239 newtons. So I've got TC solved. I got TB solved. All I need is TA. So what am I going to do to find TA?
Plug it in.
Plug it in right here. Yay!
I know.
And then we'll be done.
You said it was so cute.
TA. 1.13 times TB, which we just found to be 239, and TA is equal to 270.
Oh, I'm not really done.
And that is it.
Well, we're done.
With that problem, yes.
That was really
Yep,
easy.
I know.
And we have how many of these tonight?
I don't think it'll be all as long as this one. I picked this one because it had everything in it. Most of yours are going to be like they give you 2, and you just have to add up the vectors and get them to figure out what they equal. Oh, I put that all in.
Is tomorrow early release?
I thought last week was.
No, last week we left you not. I don't remember.
It says that it's next week, not this week.
Oh, it's the first of every month.
Which one's Fridays?
First and third.
It has pulleys on it, right?
First and third.
Okay. Okay, so I have this practice question that we can do, which is basically the same thing, so I kind of wanted to do this one instead. I don't think this one will take us quite as long. How do you guys feel about this? I mean, you guys can sit around and talk for 10 minutes, or I can do another problem for 10 minutes.
Doing it.
Okay. That was my question. Okay, so let's clear off the board here. Make sure that worked. Yes?
Wait, so when you post this online, like,
It's recording my voice and, well, what you guys say too. And it's also recording what I draw on the board. I just am having a hard time posting to Edline because it doesn't like the files that I'm uploading to it. So I'm trying to record in every different file today so that I can try to get one of them to work. If that doesn't work, I'll start posting on like YouTube or something. I don't really want to do that because I don't really want my voice all over the internet. That, or I'll have my husband make me a web page that I can post movies to and have you guys come in and look at it. But I don't know what I'm going to do yet. Depends on what works.
you can make it like a private YouTube video.
Yeah?
And just link us to it. So that's what Ms. Walden did.
Okay, that's a good idea.
Yeah, if you make it private, just have a link on
I don't spend a lot of time on YouTube other than the side shows, so I'll see if I can figure it out. It shouldn't be too hard. Okay, so here's our example. 3 cables are tied together and pulled tight. One has a force of 5 newtons at 130 degrees. The other has a force of 7 newtons at 200 degrees. What does the other force have? So basically you have 3 cables. Let's draw this out. we have three cables. One is at 130 degrees, which is like that. The other's like 200 degrees. They want to know what other cable is going to pull tight so that it doesn't move. So it's got to be, I mean, just looking at this, we know it's going to be something like that, depending on how hard it is. Like if it's pulled really hard this way, then, so if it's pulled really hard this way, we're actually going to end up pulling it more that direction. But if it's pulled really hard in the other way, like this way, then we're going to have to pull it more like that to balance it out. So based on how hard it's pulled, it's going to tell us which direction we need to pull it, like exactly what angle we're going to pull it. But we'll just kind of put that one up there as a placeholder. So let's call this one TA and this one TB. And the one that we're looking for is TC. We don't know what TC is. That's what we're looking for. This TA is the 5 newtons at 130 degrees. So this is 130. And this TB is the 7 Newton force at 200 degrees. So it's got 200 degrees here. So we don't know what TC is, and we don't know what it's at. So it's going to be basically TC at some unknown theta. You can call it theta C if you want, just to give us some variables to work with. If we look at our forces, same stuff. Sum of the forces in the x direction equals max. Sum of the forces in the y direction equals may. Since A and B have some x and some y, they're not just up and down, they're not just left and right, they have some components, they need to end up in both of these equations. So the forces TA plus TB plus TC need to add up so that it doesn't move. So this needs to be 0 because it's not moving in order for it to be pulled tight. And same thing in the y direction. You have to add up all these forces so that they equal 0, basically. Because again, you don't want it to move. That's like the force part. Once you get that, it's vectors again. So do we have questions about why this is? We're okay with this part? Okay. Excellent. So now we're going to look at these as vectors. We have TA, TB, and TC. X, Y. So TA is going to be 5 cosine 130, 5 sine 130. TB is going to be 7 cosine 200 and 7 sine 200. And here's the nasty part. TC, we don't know what TC is, and we don't know what angle it's at. So I'm going to just go through and simplify these a little bit. This is negative 3.21. This is 3.83. Cosine 200. Negative 6.58. And sine. Negative 2.39. And I can't simplify the bottom. So I'm going to look at this x stuff. X. And this is my x stuff, basically. And it's going to go negative 3.21 minus 6.58 plus TC cosine theta equals 0. And the reason that it equals 0 is because I just said TA plus TB plus TC equals 0. So TA, TB, TC equals 0. So see why getting the equation is important? Because that tells you what to do with your components after you've found them. All right, I got 5 minutes left. We're going to take the y stuff now. TA is 3.83 minus 2.39 plus TC sine theta equals 0. I'm going to simplify these equations. Negative 3.21 minus 6.58 gives me negative 9.79 equals negative TC cosine theta. You see what I did there? Move the cosine theta over to the other side.
Would that just be 9.79?
Uh-huh. Yeah, basically you can do plus and plus. So you see how this is T cosine theta? Remember your X is M cosine theta? So basically what this is saying is that this is the X component. This is I hat. And then if you simplify this, 3.83 minus 2.39, 1.44 equals negative TC sine theta. So basically negative 1.4 equals positive TC sine theta. This TC sine theta is the same thing as the y component is M sine theta. That's saying that this is the J component, the y component. Yes.
Wouldn't that be negative TC sine?
This was a positive number. I moved it to the other side and then I flip-flopped them. So this would be negative, that would be positive. Or if you help with it, would help. I left this and moved that to the other side. So I don't think she's in here. I think she left for BCC. Okay, so we have an I and a J. Now remember to get the magnitude. Magnitude equals the square root of x squared plus y squared. So this will be the square root of 9.79 squared plus 1.44 squared. And your angle is going to be tangent inverse of y, negative 1.44, over x, 9.79. Since the y is negative, and that's the only thing that's negative, we'll add 360 onto our answer. And you should be able to get the magnitude and direction from that. So 9.79 squared plus 1.44 squared. Notice that I didn't include the negative on the magnitude direction, the magnitude one. This negative disappeared because it's going to disappear anyways when we square. Okay, I got 9.89. And that's in newtons. That's our magnitude. And this is 352. And that's our direction.
Was that it?
That's it.
So the question, we would answer the question with 9.89, not with the 352.
What force? I mean, you should include the angle as well.
Oh, okay.
And on your question, it'll be like, what's the magnitude and direction? So magnitude would be the number, direction would be the angle. I wrote this question, so it wasn't as specific. Okay. There you go. There's your homework. 43, 45, 95, 96, 97, 98. If you would like to take pictures of it, some of it is in the binder, the other is on the doc cam up here. You're welcome to come take pictures now. We've got like a minute left. I'm going to try to save this.